Welcome to today's lesson. We're going to start by doing a correction for a question on the surface area, and this is how it looked like. So we are asked to find the surface area of this prism. So we had said that to calculate the surface area, you need to find the areas of the specific faces, then add them together to give us the total surface area of the object. So we said you are supposed to identify the different faces that are available in that object. So we realize that we have a triangular face up here, and it is also repeated at the bottom. We also have a rectangular face here. So what we are supposed to do is to calculate the area of the faces, that is the triangular faces, and the rectangular faces, and then add them together. So let's start with the area of the triangular faces. We know that to calculate the area of the triangle, we use the formula, a half base times the height. So what is the base length of this triangle? You see that it is 6 millimeters. And what is the height? We said the height is normally perpendicular to the base. So it should be perpendicular to the base. That means when we look at it, it is 4. So because we have the same triangle at the bottom, then instead of calculating them separately, we multiply by 2. This triangle here and the triangle at the bottom. So 2 and 2 cancels out. We'll have 24 square millimeters for the triangles. Let's calculate now the area of the rectangles. Area of a rectangle, we said which formula do we use? Length times the base. Yes. So we have the triangle, the rectangle, length times the base. So which is the length and which is the base? Five millimeters. The rectangle is measuring 5 millimeters by 6 millimeters. That is, we say now in substituting to our formula, we say 5 times 6. And because these are 2, we are told this is equal to this. That means this is also 5. And this is also 5 millimeters. This is 5 millimeters. Then the measurement here is 6 millimeters. So you realize that these 2 rectangles are equal. Instead of calculating area separately, we just multiply by 2. 5 times 6 times 2, that will give us 60 square millimeters. Square millimeters. Then we have this other rectangle. You realize that we have another rectangle. We have calculated the rectangle here for the sides, this side and the other side. We now have the base, this base here. So the base, area of the base, you realize that the base is measuring 6 millimeters by 6 millimeters. We're talking about this rectangle here. So because it's a rectangle, it's still length times base, which is 6 millimeters times 6 millimeters. That will give us 36 square millimeters. Now we have calculated the areas for all the faces. Let us now add them together to give us the total surface area. So we have 24, we have 60, then we have 36. If we add them correctly, that will be 120. So that is the surface area for this prism. There's also another correction for calculating the surface area of a wooden box. Let us look at it again. So let's look at this question again. An open box with no lid in the shape of a cube is made of wood that is 2 centimeters thick. Its outside length is 40 centimeters. So find its surface area both inside and out. So we'll start by calculating the surface area of the outside, and also later we'll calculate the surface area of inside. Then we add them together because we are told to calculate the surface area for the inside and for the outside. Find the surface area. Start by surface area outside. So you realize this is a cube. Cube means all sides are equal. That means all the faces are equal. But now we will exclude the upper side, because the upper side, we are told there is a wood that is covering it that is 2 centimeters thick, yet we are also told it is open. So this box is open. So we will include this side, the side that we are not seeing, the opposite of this, the opposite of the other one, and the bottom. Those will be the squares measuring 40 centimeters by 40 centimeters each. So how many are there? Let us count. We have this and the opposite of it, that is 2. We have this 3, the opposite of it, that is 4. The bottom face, that makes 5. So we have squares measuring 40 by 40 each. There are 5 of them. So the area of the square is given by side squared. So we'll say side squared, because there are 5 of them, we multiply by 5. That is why we have 40 times 40 times 5. If we calculate that one, that will be equal to 8,000 square centimeters. That is the area for all the 5 equal faces outside the wooden box. Now, the remaining part is the top side that is now covered. This wood, we are told it is 2 centimeters thick. We will not include here because here is open. So the only area that we will calculate is for this narrow top end that is measuring 2 centimeters. We are told from here to here is 2 centimeters. So let us see how to calculate that. What is the length from, so let us connect with the dots. If we connect here, then connect here and here, you realize that we will have to, we'll have two we'll have 4 rectangles at the top, 4 small rectangles at the top, one measuring, now we are joining from here to here so that they come from this end to this end. And we are told from this end to this end, that will be 40. So you realize we have rectangles measuring 40 by 2. This is 2 centimeters. This will be 2 centimeters. So this rectangle here is 40 by 2. It is the same case with the other one, this last one also. It is all the way from this corner to this corner, which is 40, and then the width is 2 centimeters. So we have 2 of them, which are equal. So that is 40 times 2 times, because there are 2, we have 160. Then now, because we have cut it through, so that means we are subtracting 2 centimeters on this end and 2 centimeters from this other end, meaning out of the 40, I'm talking about this rectangle here that will be formed from here to here. So you realize that we have carved out 2 centimeters from this end and 2 centimeters from the other end. So that we remain with 40, because that is 36 minus 2, 40 minus 2 minus 2. So this one will be measuring 36 centimeters. What about the length? This other length? So this is 36, and then we now have from, it is also from here all the way here, because we have this one. I'm talking about this and this. So it is 36 by 2. That rectangle is 36 by 2. 36, and the thickness is 2. There are also 2, this side and this side, so we multiply by 2, and that will give us 144. If we had the surface area for the outside surfaces, we'll have 8,304 square centimeters. Let's now calculate the area for the inside. So outside, so inside, realize the upper side is open, so that means we'll have the sides, the four sides and the bottom. The four sides and the bottom. So the four sides, you realize that this side has been carved out 2 centimeters because the box is made of wood 2 centimeters thick. So this wood is 2 centimeters thick, the other wood is 2 centimeters thick, this wood is 2 centimeters thick, and the other side is 2 centimeters thick. So then what are we remaining with inside? So you realize that we'll have 36 centimeters being the length, and the base will be 38. The base will be 38. So 36, we are talking about an inside. So it will be, this one will be measuring 36, the base, and the length will be 38, because you realize that the wood will take 2 centimeters from bottom, the bottom surface. So you subtract 40 minus 2, we have 38. How many surfaces do we have? There are 4 of them inside, this, the other side, and the other end. So if we calculate that, that will give us 5,472 square centimeters. Then now let's look at the surface, the area of the bottom side. The area of the bottom side, we have said it is measuring 36 centimeters. It will also measure 36 because the wood will be taking 2 centimeters this end and 2 centimeters the other end. So it will be measuring 36 by 36, and that will give us so the total surface area for the inside part the all total surface area will be the inside plus the outside, which we had calculated, and it was so that is the surface, the total surface area for the wood, the total surface area for the wood, both inside and out. It will give us 15,072 square centimeters. Now that was the correction for last class. Let us now start the lesson of today. Remember that in our last lesson, we had introduced on volume, and we looked at how to calculate the volume of a triangular prism, rectangular prism, and also a cube. So today, I want us to continue to learn how to calculate the volume still of prisms and cylinders, of other prisms and cylinders. What did we say a prism is? We said in our last lesson that a prism is a polyhedron with a uniform cross-section. A prism is a polyhedron. That means a face or a solid with many faces that is having a uniform cross-section. And what is a cross-section? We said last time that a cross-section is the shape that we get when we cut through an object, when we cut straight through an object. For example, let's look at an example of a triangular prism. A triangular prism looks like this. It has a face, one face, which is triangular, and also the end, which is triangular. We said a prism has identical ends. This is one end and the other is an end. When we cut through straight, at the middle here, you realize that what do we get? We'll get, let's remove this part. You realize that we'll also have the same shape and the size of a triangle as the ends. If we cut through this side again, let's remove this part. You realize that we'll have the same shape and the same size of the face that we had at the beginning. So this, we mean, that is what is cross-section. Meaning, if you cut straight through an object, you get the same shape and size like the identical ends of the prism. That's what we mean by a cross-section. So it's like, a cross-section is like seeing the inside of that object. Seeing the inside of that object by cutting it. Now, we have different types of prisms as we looked at last time. We looked at a cube, and we said a cube has all sides equal. And we said for you to be able to calculate the volume of a cube, we said you say S cubed. We said S cubed. Because when you're talking about volume, we said you are looking at the space occupied by three-dimensional object. So for you to be able to get the space occupied by this three-dimensional object that has the size being equal to the length, base, and height being equal to each other, then we multiply side by side by side, and that will give us side cubed. For us to be able to understand the volume well, let us look at an example. So here we have cubes that are arranged to form a rectangular prism. So we have the first layer of cubes. They are arranged, packed together to form the base. Then we have another layer of cubes. Then we have the final layer that is arranged and packed together to form a rectangular prism. So the question that we are supposed to ask ourselves is, the first thing is, how many cubes are in the base layer? How many cubes are in the base layer? How do we find the number of cubes that are in the base layer? So we can remove this other side, the two layers top, then we can count one by one. And because the bottom layer is the same as the top layer, we can count using the top layer. So let us count, that is 1, 2. How many cubes? There are 20 in total. 20 cubes. What is the area of the bottom layer or the base layer? The bottom layer is what we call the base layer. What is the area of the base layer? How do you calculate the base layer? You realize that the base layer, we have a square that is measuring 4 by 5. So then what is the area? We said area is equals to length times base, which is 4 times 5. That will give us 20. What do you realize? You realize that the number of cubes forming the base layer is equals to the area of the base. It's equals to the area of the base. Why is that so? Why is that so? Because the number of cubes that are at the base, the number of cubes at the base is equals to the number of squares at that base. The number of cubes is the same as the number of squares, because these are the squares that are at the base. So then what can we say? That if you count the number of cubes at the base, that will be equal to the area of the base. That will be equal to the area of the base. Area is equal to the number of cubes at the base. So the question is, if A represents the area of the base, explain why the rule volume is equals to area, or the base area times the height, can be used to find the volume of a rectangular prism. We are saying if this is the base area, which we have found to be 20, we can be able to say 20 times 3, and that will give us the volume of this rectangular prism. Why is it that we can be able to say that? Reason is because height in our case represents the number of layers. The number of layers of the cubes. The number of layers of the cubes. One layer forms the base, then at the middle we have another layer, at the top we have another layer. So if you can look at them keenly, you realize that we have cubes which are amounting to how many layers? 3 layers. The first layer, the second layer, the third layer. And we have said the first layer has 20 cubes in it. That means because it is packed at the same length, there are also 20 on the second layer, and there are also 20 on the third layer. So if we multiply by 3, we are saying there are 3 layers measuring 20, which will give us 60. So it is true that we can then be able to calculate volume by saying the base area times the height. For a rectangular prism, you realize that we can use 3 different faces to form the base. For example, for a rectangular prism, this face that is measuring 3 by 4 can be the base. because if we cut through at the middle, it will still have a uniform cross-section. This side will form a uniform cross-section still. This other side can also give us the base, because if you cut at the middle of this side, we'll have a uniform cross-section. We also have the down, the bottom, which is the base layer, which can also form the base. So for a rectangular prism, it can have 3 different faces being the base. And we are saying the base should give us an end that when you cut through across, you will have the same size and shape all through. So then what are we saying? That volume is equals to base area times the height for a prism. We have said a prism has a uniform cross-section. So So if we have a rectangular prism, the first thing that you need to identify is which side will form the base. And we are saying you should identify the side that even if you cut at the center, you will find a shape which is of the same size as the ends of that prism. So you need to identify the base. When you identify the base, then the next thing that you're supposed to do is to find the area of that base. Find the area of the base depending on the shape of that base. Then, once you have the area of the base, then you can be able to calculate the volume by saying the base area times the height. The base area times the height. So for our triangular prism, this is our base area. And our base area this time around, because it is a triangle, is a half base times the height, which then will also give us, let's call this one the length. So half base times the height, then we have the length. You multiply by the length to give us the volume. We have different types of prisms depending on their bases, the shape of their bases. For example, you realize that this one is a prism and the base has the shape of a trapezium. So we call this one a trapezoidal prism, because it has the base being a trapezium. So again, for you to be able to find the volume of this solid, of this three-dimensional object that has a base of a trapezium, you use volume is equals to A times height. And we have said A means base area base area times the height. So how do we calculate the base area of the height of the trapezium? If you can remember from your last class, we said it is a half times the perpendicular height times the sum of two perpendicular lines, two opposite or perpendicular lines of the trapezium. Under this category, from our topic of today, you realize we have cylinders. Are cylinders prisms? In our definition in our last class, we said a prism has the other sides being either rectangles or parallelograms. You realize that even for a triangular prism, we have this side formed by a parallelogram or a rectangle. But for cylinders, a cylinder has a base and it also has a height. The base is a circle, but then the height is not a rectangle or a parallelogram. That means a cylinder is not a prism. But then for purposes of calculating volumes, because it has a uniform cross section, because the cylinder has a uniform cross section, if I cut it along this end, I will get exactly the same shape here as bottom there. So this rule of calculating the volume can be applied to a cylinder, yet it is not a prism. Because the reason we have said it's not a prism is because this side is not made up of either rectangles or parallelograms. But it complies with the formula, volume is equals to base area times the height. So for a cylinder, to calculate the volume, we say base area times the height. How do you calculate the base area of a circle? Pi r squared, if you can still remember. We say to calculate the area of a circle, it is pi r squared. So that means for the volume of a circle of a cylinder, we get by pi r squared times the height. Now let's look at some examples on this topic. We are asked to find the volume of the cylinder correct to 2 decimal places. This is the cylinder. It is measuring 2 centimeters in radius and 10 centimeters in height. So using the formula, volume is equals to base area times the height. That means the first thing we need to find is the base and then the area. Which is the base? We have said for a cylinder, the base is the circle. The base is the circle, so you find the area of the base, which is pi r squared. Pi r squared is, if we substitute a radius which is 2 centimeters, we have 22 over 7 times 2 times 2. If we calculate correctly, then we'll have 12, this will give us 12.566 square centimeters. That is the area. But then for the volume, it is area times the height. Height is 10 centimeters, so we multiply the area by 10. What do we have? (125.66 square centimeter. Not square, but this is volume. We said volume we measure in cubic units. Cubic units. Another example on the same. Sometimes you are not given the radius, but you are given the diameter. So you are still told to calculate the volume of this cylinder, given the diameter is 14 meters and the length or the height is 20 meters. So how do you go about it? The first thing, you need to find the base area. Base area. Again, the base area, we are looking for the area of the circle, which is pi r squared. We have 14 being the diameter. If you can remember, we said radius is equals to diameter divided by 2. So diameter, we have 14. Our radius is 7. Substituting in our formula, sorry. We'll have 154 square meters. That is the area of the base. Then what is the volume? Base area times the height. Base area we have calculated and it is 154. If we multiply by 20, that will give us around 3,080 square meters. That is the volume, not square but cubic, sorry, cubic meters. So let's look at this three-dimensional object. We are given the base area is the top face here, and we are already given the base area. So area is 10 centimeters, 10 square centimeters. Then we are given the height. We'll still use the formula volume is equals to the base area times the height. Because the area has already been calculated, then we only need to substitute 10 times the height, which is 3. That will give us 30. So for calculating volumes of prisms and cylinders, we apply the general rule. Volume is equals to base area times the height. And then you just substitute the values in the formula and we'll have our volume. The same case with a triangular prism. We have a triangular prism. Again, the same rule applies. Volume is equals to area times the height. And you're saying this is area, meaning base area. So the base area, you look for the end that will have a uniform cross-section throughout. So the end that will give us the uniform cross-section is this side, which is triangle. This is a triangular prism. We know that the area of a triangle is calculated by saying half base times the height. So substitute the values. The height is always perpendicular to the base. So base area is 4 square meters. Base area is 4 square meters. Then now we multiply. Four, which is the base area times the height. That will give us 32 cubic meters. In volume or three-dimensional objects, still we have figures or composite solids. We also have composite solids. We also have composite solids, just the way when we are calculating an area, we had figures which were made up of 2 or more shapes, put them together. So here we also have 2 or more solids, put them together. How do we calculate volume? For example, let's look at that composite solid, an example of a composite solid made up of 2 or more solids put together. We are told to calculate the volume. Calculate the volume of the composite solid. So the way we did the surface area, we will also calculate the volume separately, then add or subtract them together. So what we will do here, you realize that we have a cube at the bottom and a cylinder at the top. Cube measures 2 centimeters by 2 centimeters by 2 centimeters because of these dashes here that tells us these sides are equal. Again, volume is equals to base area times the height. For a cube, all sides are equal. That means all sides can be the base. Two times 2 will give us the base area. Then times 2, which is the height, that will give us the volume. That is the volume of the cube. The volume of the cube is S squared H, or S, because all sides are equal. Then now we come and calculate the volume of the cube. We now come and calculate the volume of the cube. Let's calculate the volume of the cube. Sorry, it's not cube, but cylinder. We now calculate the volume of the cylinder. Again, volume is equals to area times the height. Area is given by the base. This is the base. The base is the circle, pi r squared. What we are given here is this is also 2 centimeters. What is the radius of this circle? You realize that the diameter of this circle here is equals to the side of the cube, because the circumference of the circle is touching the sides of the cube. So the radius or the diameter of the circle is also 2 centimeters. We know that radius is equals to diameter divided by 2. So what's our radius? That will be 1. Calculate the area. That will give us 3.14. Then now we multiply by the height. So that will be 3.14 times the height, which is 2, and will give us 6.28 cubic centimeters. So again, the volume of the cylinder if we add them together, the total volume of this composite solid is 14.28 cubic centimeters. So what have we done? We calculate the volume of different solids with the different shapes, then put them together. Let's look at this other composite solid. If you can look at it correctly again, you realize that we have here a triangular sort of a prism. If we connect here, then we have a rectangular prism. This is a composite that we calculate by subtracting. We calculate the different prisms, the volumes of different prisms, then we subtract. How? If we connect the dots, we'll have a full rectangular prism. So volume is equals to base area times height. And because this is a rectangular prism, then base area is length times base times height. So we'll substitute our values. We have 5 times 9, 5 length, base 9, height 5. We'll have 225 cubic centimeters. Then we calculate, this is a triangular prism that is carved out of this rectangular prism. So because this is the base is a triangle, we say area is equals to half base times the height. and the height is 9. The height is 9. That is 2.5 base times the height. So the volume of the triangular prism is 54 cubic centimeters. For us to calculate the volume of this cube here, we have said we subtract the area or the volume of the rectangular prism minus the area of the triangular prism. So the area of this rectangular, of this prism is 171 cubic centimeters. So today we have learned about volume of prisms and cylinders, and we have learned that a prism or a cylinder has a base and also has a cross-section, which uniform cross-section will give us the height. So for us to be able to calculate the volume, we have said you multiply the base area times the height. And we have realized that though the cylinder is not a prism, it has also a base and a uniform cross-section, which now can allow us to use the same formula to calculate the volume. And for composite figures or solids, you've seen that you calculate the volumes of different shapes or different solids, then you can either add them together or you can subtract depending on the type of the solid. And that brings us to the end of the lesson. Thank you.